Is that working now? Got it? Okay. Hi. How y'all are? Sorry about that. I'll mute next time I got a cough. My name's Steve Larson. Sorry for my voice. I'm coming off of the flu. I'm not contagious anymore, so don't worry about that. And I'm going to tell you how not to make an expensive paperweight out of your SSD, or how to make one. I don't know. First of all, I've got a disclaimer. Neither am I. That's my disclaimer. So, and you'll see why later. Okay? We'll talk a little bit about data erasing fundamentals for those of you that don't know much about it. And then we'll talk a little bit about the issues that we have with erasing SSDs. So we know that deletion of data doesn't mean it's going to be destroyed, right? If you pick up a book, this is what I tell my intro students. And imagine that this is a book. When I'm erasing a file out of the book, what am I doing? If I'm erasing a chapter, and it was a hard drive. Yeah. In other words, all I'm doing is I'm taking the entry out of the table of contents. Well, actually, yeah, I'm not even doing that. I'm just making it so it doesn't appear to the OS, right? So taking it out so the OS can't see it. If I'm going to format the drive, I'm just getting rid of all of the list of the files that are on the drive. But all the data is still there, no matter what, right? And the text is still there on the book and stuff like that. So we know that this stuff doesn't work. So generally what we do is we wipe a hard drive. And who can tell me what wiping a hard drive means? I can pick on somebody from Slippery Rock University that I know knows it. Yes, sir. I'm sorry, I didn't hear that. You overwrite every single bit on the disk, right? With some kind of random 0 or 1 or something. Yeah. And that way we can't get the data back. Yes, sir. I don't care what you record. I'm not coming through on the video. Well, that's because it's pointing way up here. Oh. Am I an HDMI? No, I'm a VGA. Okay. When it comes to SSDs, we have a different technology, so we got to use different methods, and sometimes we don't know what's inside the black box. So y'all know about hard drives. These are the spinning platters that we all use and all love to use. You know, the OS has direct access to writing to the hard drive. We can say, go to this address on the disk and write this text. There's no real state for the page. You know, all we have is read and write. We really don't have a delete on there. When it comes to SSDs, the OS does not have direct access to the pages. Excuse me. And then we have a wear leveling issue that we'll talk about later on. And each cell has a state to it. Okay, so NAND memory, which is what's inside SSDs, has 3 operations. We have the read operations, the write operations, and the erase operations. When we write to the blocks on SSDs, it can only be written once. If you're going to overwrite it, then of course you have to completely erase it and then be rewritten. And a block or a page has a state. It's either programmed or it's erased. They're organized into blocks. You start off with all bits set to 1, so everything on the SSD is set to 1. That's the erase state. When you write a block, you set the necessary bits to 0, and then you get your 0s and 1s, and so now we have our data, and now we're in a programmed state. And we can read that block repeatedly. We can read it all the time, anything we want to do. Unfortunately, reading it too many times will cause problems with the nearby blocks. Why is that? Who here knows about static electricity? Yeah? Do you like being shocked by static electricity? No? Why not? It doesn't hurt. A little bit, yeah. But you know, it's temporary, right? 1s and 0s don't like it. Why is that? They might change the state, right? You get electrical shock here, and it might hurt here a little bit, or something like that. You know, kind of like a nervous system. So that's the closest we can come to why. We're shooting electrons at these guys to change their state, and the nearby cells that are getting shot might start to be affected. So, you know, SSD is a little bit more complicated than hard disk drives. When we need to update even just one little bit in an SSD, we have to first erase the entire block. So we copy everything into RAM, SSD RAM, and then we erase the entire block, and then we rewrite the whole thing. There's a 50-50 chance that you only have to put in a 0, but if even one little bit in the entire block goes from 0 to 1, then we got to read the entire block into RAM, update it, erase the block, and rewrite the block. Okay? These program erase cycles can only happen a certain number of times before they wear out. It's kind of like if you get that little static electricity shock, pretty soon the little nerve ending in your skin that's receiving that shock is going to wear out, right? It's going to get numb, and you're not going to feel the shock anymore, so it's kind of useless. And also, some chunks of data get updated more frequently than others. There are certain files that we use on a daily basis that get updated all the time. Every time you press Control S to save something, then you know the file gets updated. And then there's some data that we don't update hardly at all. When was the last time you changed the JPEG? I don't remember the last time I changed one, right? Every cell in the SSD every cell in the SSD has a certain number of program erase cycles that it can go through before it gets worn out. And when it does, we have our mean time between failure level that's marked onto it, and it says, look, you know, before we fail, we want to write this someplace else, and so then it will put it someplace else on the SSD. Because of this, the manufacturers have wear leveling, and they also do over-provisioning. So wear leveling is, we want to make sure that the SSD doesn't get worn out in any particular cell. So in other words, if we can write something to cell A1 100,000 times, cell A2 has nothing, then cell A1 is going to wear out quicker than cell A2. So we don't want that to happen, so we put this wear leveling in. And what that does is it means, you know, data is going all over the place. Excuse me. I got to numb up my throat here. Oh, that I can't talk. That's 80, right? Okay, so anytime a cell gets rewritten too many times, we get to the mean time between failure, and we write the contents of that cell someplace else, and we mark that cell as, or its block as, don't use. Now, does this cause the drive to get smaller over time? You would think so, right? Does it? Has anybody noticed their SSD, the available space? I know the available space gets much smaller, but has anybody noticed that their disk gets smaller? Does anything report that it gets smaller? Not really. I don't think the firmware lets it happen, right? The firmware doesn't tell us. By the way, you know, you've now got 17 blocks marked bad, and you now have 1 megabyte less on your hard drive, right? We also have a thing called over-provisioning in SSDs, and I'll show you a different graphic on it later on, but basically because of this wear leveling and cells can wear out, they add between 7 and 20% more space in your SSD than is advertised, because if we mark it bad, we don't want you to think you're running out of space. So I've got a 64 gigabyte SSD here. As you can tell, it's not as new as we would like. It's a little bit older model. But that means it could have, you know, up to what? 1/5, right? What's 1/5? 12 extra gigs on here that we don't know about. So when we write a file, for example, our balance sheet. I'm an accountant. I've got a balance sheet. How many times a day? Any accountants here? No? How many times a day do you update a balance sheet? I guess it depends on your company, right? You're doing Walmart, you get 100,000 sales a day, you might be updating that balance sheet 100,000 times. Okay? When you write it too many times, we're going to do some wear leveling, and we're going to take it off of one cell and put it in a different cell, and we're going to update a couple more times, and this is going to happen, and then we go back to the first cell that we were in, and then we realize, uh-oh, that cell's been updated too many times. Now we're going to mark that as bad because we don't want that cell to go bad, and we're going to put the balance sheet now is going to be up here. Oh, I don't have a mouse anymore. We're going to put that balance sheet up here in the top, which is where our over-provisioning is. So we didn't put it anywhere else. Now we're in the over-provisioning state where we're going to add that balance sheet. Okay? So the biggest thing that impacts how much space you have available on your SSD is how dynamic your data is. So if you're changing the files all the time, then maybe you don't want to use an SSD. Yes, it's fast, and yes, they are reliable now, but you could wear out real quick. So I hear of a lot of companies using SSDs in their servers, and I say, you know, that's a smart idea because it's, you know, really fast to read and write data, but you're going to be wearing out your SSDs real quick, depending on how dynamic your data is. And they haven't understood that part yet. However, not all is lost, right? The SSD controller makes sure that all pages get programmed and erased about the same number of times, so we have our wear leveling and stuff like that. And of course, there's the larger pool of spare over provision space. Now that space is only accessible by the SSD itself, by the firmware. So we have our spinning disk, we know everything, where things go and stuff like that, and we've basically got access to just about all of it except for the, you know, sometimes the notebook manufacturer, the hardware manufacturer will say, I want to put this aside here so in case I have to recover something, I've got a recovery partition and stuff like that. But we basically can get to every single part on a spinning disk. When we go to an SSD, we have some invisible areas that the OS, that the operating system can't see. And it's really interesting because, you know, I've got 64 gigs here, but I've got maybe up to 12 gigs that I cannot see with my operating system. And that's the over-provisioning part. In case these cells over here go bad, I need someplace else to remap them, okay? Now, SSDs are gaining in popularity, of course, and the best way to get popular when you're a hard drive manufacturer or an SSD manufacturer is to make the SSD look like a hard disk drive. So if you look at an SSD with, I don't know, a hex editor running on Windows, it's going to look basically like a hard drive. You're not going to see much difference, right? And they do this by following, you know, these ATA commands and stuff like that. They actually have to have what's called, let's see if I can get this up here, this flash translation layer. So the flash translation layer tells the operating system, okay, you've got these ATA commands, which has been going on for, you know, like a decade, and treat it just like that. So we're going to take the ATA commands and we're going to write things to our SSD, just like you were writing them to the hard disk drive. So when we write something to a hard disk drive, yes, sir. It's the, yes, it's SSD firmware, which raises another question, right? Every single manufacturer has their own flash translation layer, right? Yeah, it's firmware inside here, right? So when we tell it write to something on a hard disk drive, we say go to this page and write stuff. When we have our flash translation layer, we say go to this page and write stuff. But if that's been written too many times, then we're going to go to someplace else and we're going to put it there. However, we're still telling the operating system we know where it's at and here's where it's at. So unfortunately, what happens is that can leave some stale data all over the SSD. We also have some other issues. What if we want to wipe that SSD? Military specifications. How many times do we overwrite for mil-spec? Up to 35, right? Depending on the confidentiality level of the data, right? One project I was on, I did a stint with SCIC, and one project I was on, we had to not only do all these overwrites, but then we had to sandblast the disks, and then we had to melt them down. So I don't know why we just couldn't melt them down to begin with, but you know, this is the military, right? Okay. Unfortunately, we can't access all the pages with an operating system on here because we have over-provisioned data that will still contain data in the over-provisioned space. Also, anybody dealt with freeze lock? Yeah? You like it? Of course not. It's inconvenient. But you know what? We trade convenience for security, right? So we have this thing called freeze lock, and it's basically so we don't mistakenly wipe our SSD. or our hard drive itself, okay? Some other issues, SSDs are fairly new. That's why they got this flash translation layer in, so people will accept it, because computer manufacturers don't have to come up with a new way to access the SSD, because we can just use the ATA commands that we've been using for over a decade. ATA secure erase, that's in the firmware and stuff like that. It doesn't work very well with SSDs. A guy down at UC San Diego and his team tried 11 SSDs that say they supported the ATA secure erase command, and only 8 of them supported it, and 3 of those had a buggy implementation where it wasn't reliable. So out of 11, we really only had 5 that they said you could actually rely on for secure erasing. Okay, you can do a cryptographic erasure. It works on hard drives or SSD or whatever, and you just delete the key. You encrypt the entire disk, and then you delete the key. Bruce Schneier says that's great if you're implementing it perfectly, and it's got to work perfectly every single time. And the other thing is, yeah, we could do that, but what happens in 3 or 4 years when somebody breaks that cryptographic key, and then they can get in at your data? And, you know, for us, we really don't care. Who has data from 3 or 4 years ago that they still use? 1? That wasn't a hypothetical question. You know, this is a real, yeah. 1, 2, 3, or 4. Yeah, not very many of us though, right? And if you don't do the cryptography wrong or correctly, you know, you can have some problems. Now, how would that be? Would that be easy to break? Just stand it upside down, right? Okay. So when we're doing erasure on SSDs, we got to deal with the FTL and the freeze lock and stuff like that. We've got to have the OEMs got to cooperate. They have to actually perfectly implement their secure erase or their version of secure erase on the ATA commands. The secure erasure has to be verifiable. Can we verify and prove that it actually happened? And how are you going to verify that? If your operating system, how many of you use a hex editor or something like that to view data on a hard drive without having an operating system? Yeah, how would you do that? How are you going to verify that there is no data left on here? We just have to trust the OEMs, the people making these SSDs, and implementing that firmware. And once they've said they've done it, you know, they have to report it. Well, how do you report it if you don't know if it actually happened? So here again, we have to rely on their implementation of a flash translation layer. What doesn't work, here's some things that myself and some other researchers have tried. Logical erasing, formatting, the secure erase, we know that doesn't work. Cryptographic eraser, we delete the key, which kind of sanitizes the data, but you still got data on the hard drive, and maybe in the future somebody, you know, will find that SSD and they'll be able to decrypt it. Because, you know, we're humans and everything we make is imperfect by nature, so perhaps one of these days somebody will be able to break the encryption. And then we have traditional overwriting, but when we do that, we're going to overwrite stuff. However, some of the stuff that we're overwriting, the SSD is going to say maybe that should be over here. And then we have stuff, stale data left over on the parts of the SSD that we don't have access to because of the operating system. Now, what might work if you want to reuse the SSD? There are some people out there that have solutions. Blanco, ESA, part of Magic and stuff like that. But when you use them, how do you verify it actually happened? Like Blanco, they'll give you a report. Yes, we sanitized this SSD. Well, heck, that's good enough for me. I can throw that away now, right? They said that their solution works. Who am I not to trust them? After all, I paid $129 for that software, right? So they wouldn't lie to me, would they? Well, maybe to Grandma. Grandma would believe him, right? But, you know, we're a little bit smarter than that. Here again, we got manufacturer's utilities. Ars Technica also did a study, and they had 12 drives. Only 4 erased their data reliably, and one of those claimed that they were doing it, but all they did was, just the basically format thing. So we got 3 from them. Okay. You could overwrite multiple times and use the secure erase and use a firmware initialization that should be able to do that. That hasn't worked reliably in the past, as Wei found out. And also the freeze lock, you need to overcome freeze lock. And all you got to do for freeze lock is you got to go to sleep for a little bit and then wake it back up. The Non-Volatile Systems Laboratory said that they bypassed the FTL and got to the NAND, but they had to develop new flash translation layers. They developed new extensions to it and stuff like that so they could directly access the SSD so they could make sure that they sanitized it. Now, here's another one of these. I'm not a smart man, guys. I took this little SSD here. Somebody gave this to me and they said, hey, can you check this to see that everything is completely erased off of it? And I checked it, of course, and guess what? There was data all over the place. Unfortunately, I was checking it with a software program that was running on top of an operating system. And guess what? The operating system can't see the over-provisioned part of the SSD. So how was I supposed to verify that this was totally able to come here and be thrown away? I couldn't find a way. And then my wife said, well, don't you have forensic tools at your disposal? So I said, hey, I do. I wonder if this will work. So I did a bit copy from a hard disk drive to this SSD using a Tableau forensic duplicator. Guess what happened? Bit copy, bitstream copy. The FTL did get in the way, right? Just going to tell me do this, do this, do this, do this, right? So did it work? Not quite. I couldn't access it with the operating system anymore. So I tried Parted Magic, and here's what came up in Parted Magic. So I have 64 gigs. And when I open it up in Parted Magic, I got this RID or RI data, right? So what is this? So 1, 2, 3, what is that? 8.7 gigs? No, 8.7 gigabytes is what it's reporting. Well, if I did the bitstream copy of this, shouldn't there be nothing on there? That's bytes. That's how much space is on this hard drive. I'm looking at the bottom one. It's the RI data one. So I got 8.7 gigs that Parted Magic is saying is available on here. But wait a minute, I did a bitstream copy from a 64 gig to 64 gigs, so I should have 64 gigs of space available to me, right? Minus a little bit, I could figure a couple of megs for over provisioning because we had to use it, and the cells got written too many times. So then I thought, okay, we got that much space there. And then I selected it because in Parted Magic, you select which disk you want to run this on. And I did a wipe. And when I did that, it reported a different number. And I was thinking, what? Well, I'm doing this in Parted Magic, but I was also doing it on a Linux distribution. So here again, I've got an operating system going up against this SSD and the flash translation layer not telling me, everything that's going on. So of course this is unreliable. I set it to wipe anyway, and lo and behold, I did it on 3:30 in the afternoon, and I realized, well, this isn't making very good progress here. So I came back the next day, and it was, oh golly, 19 hours, I think, or something like that, when it finally finished. And when it finally finished, it said, hey, success, we're done. So then, of course, I connected up to my Windows system, and guessy whaty? Hey, you know what? I need to format this drive. So I connected it up to my Windows system, and I said, okay, I'll format this drive, NTFS, no problem, 64 gigs, or maybe 8 gigs, or maybe 4 gigs, whatever the size is. It shouldn't take too long. And I even did the little, I unchecked the box, so it's going to do a quick format. And it failed on the quick format. But it took about 3 hours to fail. So then I thought, well, what if I do a full format? So I checked the box to make sure it doesn't do a quick format. And 37 hours later, it failed. Yeah. So it's like, oh, okay. Good thing it's spring break and I don't have to go teach or anything. So now I have an expensive paperweight because not only can my OS not see it, Parted Magic couldn't do anything with it. I tried that. OS can't see it. So this is how you get rid of it. Now, is the data gone? According to researchers and according to what I would think I still have data on here. I'm not trusting anything. Wei and those guys, they wrote data to an SSD and they put fingerprints on it so they knew exactly what data they personally wrote and so they could find it again. And they did overriding about 20 times, up to 20 times. It's been reliable, and they said, you know, the built-in sanitize commands are effective when implemented correctly, but they're usually not. And so they ended up making 3 of their own flash translation extensions to sanitize files and disks, SSDs. Now, when you really got to get rid of the data, what do? Well, you could do physical destruction, right? Take this off and take the motherboard out and all that kind of stuff. But you could still get data off of the chips. We had a chip off thing yesterday, right? So, or was that today? That was this morning, right? You could still get, was that this morning? That was yesterday, right? You could still get data off the chip. I've got a colleague at George Mason University. He and I are working on chip off information from point of sale devices. So, you know, the little telephone size things are in the restaurant and you swipe your card. If they don't get a response when they put in the phone number, if they don't get a response in 5 minutes, they spit out a receipt anyway, and then they batch process all of the leftover transactions that night. And if somebody comes and swipes that before the batch processing gets done, then they could have a whole bunch of information on their hands. Well, we couldn't get any of the information out of the chips that when they were connected to this device. So he has a team now that's doing a chip-off retrieval of the data. And he said it's not very fun, but it's still possible. If you do want to disintegrate or pulverize or melt it down or whatever, be sure you check the laws in your local area for electronic disposal waste or electronic waste disposal, because there are some parts of the country where you can't throw that out in the garbage. Just something fun. I went on a business trip to China, and we were looking at electronic waste disposal stuff, and they brought us to their factory. And so are there any heavy metals in motherboards and chips and stuff like that? Yeah? Like what? Mercury? Anything else? Lead? Yeah, there's some gold and silver and copper and tin and, you know, stuff like that. Well, they brought us into this factory, and they had workers on a table, and they had little chisels and pointy hammers and stuff, and they were going breaking these things off. They had some people that were melting some solder off of it and stuff like that. And I said, what are they doing? Oh, well, they're dismantling it, and then we're going to melt the metal down and, you know, separate them out and stuff like that. And I said, well, what about the mercury? Oh, we're not worried about the mercury. And I'm thinking, I'm not getting any closer to that. I'm worried about the mercury. Evidently, when you have more than 1 billion people in your country, you know, you lose a couple to mercury poisoning, you really don't care, right? Okay? So basically for SSDs, here's some more information if you want to read more, and this is a very short list of places. So if you want to securely delete data on the SSDs, right now I would say pulverize or melt or something. But whatever you do, you gotta get rid of those chips. Yes, sir. Pardon me? BloomCon says that they've got a really good solution, BLANCCO. However, we are relying on their own reporting. So self-reporting, I mean, I have not seen them given to NIST. You know, NIST has some stuff right there, but I haven't seen them tested by NIST yet. Oh, yeah, the UC San Diego guys made FTLs. Those haven't been made publicly available yet. Yes, sir.
So this, having to pulverize, does that apply to hybrid drives as well?
Yes, anything with an SSD as part of it. Now, you don't need to pulverize the spinning disk part of it, but yeah, the chips. Yes, sir.
Did you
To destroy for SSDs?
No.
Oh, for any hard drives? Oh, really? Wow.
Yeah, I thought that changed.
Well, I haven't worked for the government, or for that part of the government for a while. So.
Okay. But I would definitely make sure if you're referencing the DoD piece,
Right.
just double check.
Double check to see what it is. Yeah.
Make sure, I think it is now destroyed. It was
Right.
changed partially in line
Of SSDs, yeah. Yeah, and NIST put out a new one in 2014, a new data disposal thing. So, and theirs actually says, you know, depending on the confidentiality levels, here's what you need to do and stuff like that. So, yes, ma'am. Sure. Exactly. Yeah, you can't trust the manufacturer when he says, "Oh yeah, this got sanitized. We're good to go," because they're doing their own reporting. There's no third-party objective checks and balances on this. I guess there's nobody verifying that. And I wish Consumer Reports would come out and say, "Oh yeah, this one works," but do we trust Consumer Reports anymore? Some people say yes, some people say no. I mean, they're paying, the vendors pay for them to do the report, so. Well, if there's no other questions, then I know I'm the only one waiting between you guys and getting presents, so, or prizes or whatever it's called. Is that in here or is that next door? That's next door. Okay, we have to wait on them. So, sorry. I would give this as a prize paperweight to somebody that wants it, but since there might still be some data on it, I'm not going to do that.